We present a neural network mode for PX4 to be used on embedded flight controllers. The goal is to provide an open source pipeline for both training and deploying neural policies to real-world platforms. This will lower the barrier for doing research on neural networks on aerial robotic platforms. We start by training a policy in simulator for position control. We then convert this to a format compatible with embedded flight controllers. The policy is then added to PX4, which we build and flash to the flight controller. We can then switch to neural control in flight. The entire pipeline is open sourced, so anyone can use it for their own research. First, you can download the aerial gym simulator and configure what policy you want to train in the PyTorch framework. Then, a Python script is used to convert the network to C source code, compatible with embedded flight controllers. Secondly, there is an open source fork of PX4 with support for neural control. This will be merged into the main PX4 repository at a later date. Download and install the custom PX4 fork and then paste in your converted network. After building and flashing the control policy, it is available as a separate flight mode in PX4. For training and converting, we use the Aerial Gym Simulator. It is a modular, highly parallelized simulation environment for training neural networks for arbitrary multi-rotor configurations. The simulator offers out-of-the-box support for control and vision-based navigation tasks. Aerial Gym also includes the Python script for converting PyTorch networks to C source code that can be used in PX4. The PX4 module is the main contribution of this work. It provides a customizable module for neural policies on off-the-shelf embedded flight controllers, so that real-world testing of neural policies is more accessible. The modules support networks from any framework, as long as you're able to convert them to the correct format. And it is already built for multiple standard embedded flight controllers like the PixRacer Pro and the PixHawks 6C. In this work, we trained an end-to-end position setpoint controller. The controller consumes position setpoints and moves the drone to the setpoint by providing direct motor commands. Since the neural control comes as a separate flight mode, it is possible to switch between classical controllers and neural control at any time during flight. We have demonstrated the capabilities of the pipeline by deploying a train policy to an aerial robotics platform. The results show that the module is able to achieve close to sim performance in the real world. By being able to build the neural policies together with PX4 on off-the-shelf hardware, the pipeline is accessible for most researchers. Since it is built together with PX4, the PX4 autopilot software can handle everything outside the policy use case, like safety features or tools like Kalman filters. As an example, we use the standard controllers for safe takeoff and landing before switching to neural control. The standard controllers can also be used as a safety fallback.